Hi, this is Mr. Harris, and I'm going to demonstrate how to make a hyperbolic paraboloid with origami. And this is an envelope that I've already started to tear. And you can start it off with any envelope like this. So I'm tearing the edges off of the envelope flaps. Now I've got a rectangle, but I really need to make it a square. So I'm going to make this a square. I'm going to take the opposite corner of this rectangle piece of paper and fold it till I get to the other side of the rectangle. And the rectangle should fold with one edge of the paper neatly aligned with the opposite edge of the paper. This triangle shape that you will start to see should be at a 45-degree angle at this corner. As you can see, hopefully, this is a triangle shape here that is right next to this area here that's another rectangle at the bottom. I'm going to fold that rectangle behind the triangle. Folding the rectangle neatly behind the triangle. I should start to see a shape like this. Now I'm going to neatly tear the rectangle along the line where I folded it. Now I've got a square piece of paper, and yes, I tore off part of the name, hyperbolic paraboloid. This is a mathematical term that I'll explain a little later, but right now, just understand that now you've got a square piece of paper. A square piece of paper will be folded in half diagonally to form a triangle with a right angle, and that's called a right isosceles triangle. It's a right isosceles triangle because it has two equal angles of 45 degrees, and it has one right angle, which is of course 90 degrees. Now I've got this triangle. I'm going to fold it in half again. I'll fold it neatly in half so that the opposite corners match each other. From here, I'll have a smaller right isosceles triangle. I'm going to fold up the bottom evenly, right up to halfway. Well, maybe not halfway, more like 3/4 the way up the triangle horizontally. I'm folding this triangle horizontally upward to right about there. Note that I've folded it evenly, so it's not leaning to this side or that side. It's folded pretty much along a horizontal fold, and you can say it's a boat shape. Now I'm going to take the top of this boat and fold that down neatly along the same edge as the rest of this boat. Press it down good with my fingers. Now you should see a thin trapezoid. When I explain this to kids, I call it the skinny boat. Well, now I'm going to fold the skinny boat again. I'm going to fold it lengthwise. I'm going to fold it again. And now I've made the skinny boat even skinnier. You can see just this very thin trapezoid of paper. Now I'm going to unfold it all. Then I'm going to take a pen or a pencil, and I'm going to trace along the fold lines so you can see. Watch very carefully. I've drawn two diagonal lines across the square from where I folded it, and I'm going to draw more lines that go around the inside of this square to make basically a ring of concentric squares inside this, and it'll make a kind of a, I don't know, sort of a spider web pattern. Here's one square, smaller in the middle. In fact, I could probably make an even smaller square. There's a smaller square in the middle. And here's another square surrounding the first two squares. Here's another larger concentric square, and you get the idea. I'm going to draw the other squares going around this along the same pattern where I folded the shape. I am just drawing freehand. If you do this yourself, you can use a ruler. If you like very straight lines, and I like very straight lines too, but it's 3 a.m., so I'm a little more casual in the early morning hours. Here are the concentric squares that make this design. Now you're going to use this to do the final part of folding the shape. First, you're going to go to the corners and just fold along the diagonal lines. Fold along each of these corners going around the square. Make sure that you're folding the corners in the same downward direction. Alright, each of these corners, 1, 2, 3, 4, are folded downward. Now I'm going to fold edge of each of the squares. It will be in a kind of a zigzag pattern. That means I'm going to fold up, fold down, folding up, now I'm starting to see this hyperbolic paraboloid shape. I've folded the edges of this first square pattern going downward. Now, flipping the paper over, I'm going to fold the next square shape going up. Like I said, it's a kind of a zigzag folding pattern. Alright, now you start to see the pattern starting to form a little more, and these lines that I've drawn help to see the pattern even more clearly. Now I'm going to fold this smaller square inside in the opposite direction from where I folded the previous concentric square. You can see there is kind of a up and down zigzag pattern with each layer of concentric squares. As I go closer and closer to the center of the shape, I'm going to keep folding until I get to the middle. This is the middle, of course. What I can also do is pinch the corners as I fold each layer. So I fold each layer of squares. So the pattern is preserved more clearly on the paper. Now I'm really getting closer to the middle. Getting very close to the middle. And as I keep pinching the corners of the shape, it'll start to look like a cross or an X. Well, that is not what the shape is going to ultimately look like. But it's good to fold it like this for now. And you'll see why toward the end. Now, I reach the middle. And a little trick I've learned is that if I want to even get to this middle square here, just kind of press it a little bit with your finger on one hand while squeezing the X shape from the outside with your other hand. So press this in with one hand, one finger, then squeeze the whole X pattern together and go around each spoke of the X so your folds are nice and clear. And now we're going to unfold the whole thing. And this is a hyperbolic paraboloid. And one good thing to show kids is that you can make it pop it and turn it around. It can become a very flexible origami shape. And lastly, I learned about making the shape from watching the video Between the Folds. It's about origami and education and science and a lot of other things. Look up a professor named Dr. Jeremy Schaefer. He is the mathematician / artist who came up with these designs, and he teaches at MIT, which is a very famous college in Massachusetts. And thank you for watching, and I hope to have this posted up somewhere where my students can see this. Here's the shape. The other name is hyperbolic paraboloid. hyperbolic. Cut the D off when I made the shape, but there you go. Thank you.